The story of Archimedes' heat ray is a captivating narrative that straddles the boundaries of history, legend, and science. This tale involves Archimedes, one of the most renowned mathematicians and engineers of ancient Greece, who allegedly devised a powerful weapon to defend his city Syracuse during the Roman siege from 214 to 212 BCE. The purported weapon, known as the heat ray, supposedly set Roman ships on fire by concentrating sunlight onto them using mirrors or polished shields. In the historical context of Archimedes, the conception and potential implementation of the heat ray can be understood through a detailed examination of three critical elements: the shape of the mirrors, the number of mirrors, and the mechanism for synchronized movement to focus the mirrors. These components must have worked in concert to achieve the desired effect of concentrating sunlight on Roman ships to set them ablaze. First, consider the shape of the mirrors. The optimal shape for concentrating sunlight would likely be parabolic. Parabolic mirrors have the unique property of focusing parallel rays of light onto a single point, making them highly effective for this purpose. Archimedes, with his profound understanding of geometry, could have theoretically designed parabolic or similarly concave mirrors. These mirrors would need to be made of a reflective material, such as polished bronze or copper, which craftsmen of the era could have produced with the necessary skill. However, creating perfect parabolic mirrors might have posed significant challenges due to the technological limitations of the time. It is more plausible that Archimedes employed an array of smaller, flat mirrors, each meticulously aligned to reflect sunlight onto a common focal point. This approach would be more manageable and achievable with the resources available in ancient Syracuse. The number of mirrors is the second critical element. Using numerous smaller mirrors instead of a few large parabolic ones would necessitate precise coordination to ensure they collectively focus sunlight on a single target. The more mirrors involved, the greater the complexity in maintaining this focus, especially as the sun moved across the sky. Archimedes would have needed to calculate the optimal number of mirrors required to achieve sufficient concentration of sunlight without overwhelming the capabilities of the synchronization mechanism. The synchronization mechanism is the third and perhaps most crucial component. For the heat ray to function effectively, a robust system was necessary to adjust the mirrors in unison, ensuring they remained focused on the target despite the sun's movement. This mechanism could have involved a combination of gears, levers, and pulleys designed to alter the mirrors' angles collectively. Operators, possibly guided by Archimedes' precise calculations and observations, would adjust this mechanism in real time, maintaining the focus of sunlight on the enemy ships. In terms of implementation, the historical context suggests that Archimedes might have positioned this array of mirrors on high ground with a clear view of the attacking fleet. This strategic location would maximize the duration of sunlight exposure and the effectiveness of the device. Skilled craftsmen would have been responsible for creating and polishing the mirrors, while trained operators would manage the synchronization mechanism, adjusting the mirrors based on the sun's position and Archimedes' instructions. Archimedes' extensive knowledge of geometry and mechanical engineering, coupled with the available craftsmanship, made the conceptualization of such a device within the realm of possibility. The alignment of these three components, optimal mirror shape, adequate number of mirrors, and an effective synchronization mechanism, was crucial for the potential success of the heat ray. While the historical accuracy of Archimedes' heat ray remains a matter of debate, exploring its feasibility through these interconnected elements reveals that the idea was not entirely beyond the capabilities of his time. Archimedes' genius lay in his ability to combine theoretical knowledge with practical application, making the legendary heat ray a fascinating example of ancient innovation